29. Okay, and 19 students have already joined. Okay, so wait for 1 or 2 more minutes, and then we should start. Okay, so okay, fine. Now we should start, right? So 22 participants have already joined. Okay, fine. So my screen is visible to you all. Is it visible to everyone? Yes, good. Fine. So compiler designing. The subject code is CSEG3015, compiler design, right? Uh, that's your preliminary part of your compiler design. Is it or readable, or should I increase the size? I think this would be better. Okay, so the preliminaries of this course is you should have a knowledge of programming language. You should have knowledge of finite state machine and finite state automata and context free grammar and basics of computer architecture as well, right? And the textbook for this course is Ullman Aho, Compiled Principle, Techniques and Tools, right? You already know the grading part, midterm 30%, end term 50%, assignment, quiz, attendance. Uh, but here, this time we won't consider attendance that much, right? In online mode. So the proposed course outline is initially we will discuss about introduction of compiler, then we will move ahead with different phases of compiler, which is lexical analysis phase, syntax analysis phase, and we will discuss uh, in much more detail about these things further, right? So then this is again a syntactic phase, syntactic analysis phase, intermediate code generation phase. Yes, Sharans, tell me what happened. Sharans, you raise your hand. Yes, tell me what's the issue. Okay, okay, fine. So uh, there are different phases in compiler, like lexical analysis phase, syntactic analysis phase, semantic analysis phase, intermediate code generation. All these phases, all these things we will discuss in due course of time, right? So without further ado, let's start with compiler. What is a compiler? What do you mean by a compiler? Can anybody tell me? You can unmute yourself whenever required, right? So can anybody want to tell me about what they feel about what is a compiler? No? Okay, fine. So a compiler, high level language to machine level language, converts high level language to machine language, convert byte code into machine code. Okay, high level to low level. Fine, all of you are correct, right? So basically, a compiler is fine, fine. All of you are correct. That is okay. So conversion of high level language into machine level language or low level language or byte code, machine code, all are correct, right? So these all are the component of compiler, or the all are the functioning of compiler, right? So hence we can say that a compiler is a component that takes a written program in a source language and translate into an equivalent program in a target language which is recognizable by a particular machine, right? Compiler is required for a machine, right? So that a human can interact with the machine, so a compiler is required. So compiler is basically conversion of some written program or written text into of which is called source language, and it translate into an equivalent program in a target language. Target language may be your assembly language, may be your machine language, may be your um, machine code, etc., right? Okay, so initially we have defined compiler in this way, right? Then source, this is your block diagram. Any source program is given to you, source program is given, compiler take as an input, and it will produce some output as a target program, right? So source program normally a program written in high level language, right, which we are talking about high level language, because why to require compiler is required just because a person who is writing a program and that need to be converted to machine understandable form. So definitely person is writing any program, then it is belongs to high level language, and low level language or assembly level or machine level code, it is your that is your target program normally equivalent to the program in machine code or relocable object file or any other code, right? And if in between that, if source program is not able to convert it into target program, then definitely there should be an error message. So there is an error message generation as well in compiler, right? So this is basically your block diagram of compiler. It takes source program and then convert into target program, while if it is not being converted into target program, or along with conversion of target program, it may produce some error as well or warnings as well, right? So that is the functioning, and that is the block diagram of functional block diagram of compiler, right? Now uh, let's come about and discuss about why it is required and what is a machine language, right? What is a machine language? Machine language is the language which is understood by computer. And again, machine language varies from computer to computer, because some computer is having uh, 5 register. So it work on those ways, like register 1 2 3 4 5. Some computer may have 10 register. So all this the functioning and the internal memory machine language of any machine depends upon machine to machine, and for each machine the language is different, because there are different memory locations, there are different nomenclature of memory, there are different capacity of memory, right? So that's why machine language differ from machine to machine, right? So in earlier to 1940s, this machine language was the only choice, right? There was no higher level language or never nothing, only machine language was there. So and at that moment of time, at those era, the machine was also used to size of one room. It is having size of one room or one bigger room. It means ki the machine is also required a huge space, right? And at that moment of time, the computation capacity, the memory capacity or space capacity, these all are very less, very less, right? So and that much less that we can even remember those things by their address location, by name, or etc etc. And definitely if the size is very huge, but complexity part, it is very less, very less computation, or power of computation is very less. Means, say suppose only you can perform addition, subtraction, or something like that. So definitely if the number of operations is very less, and there are number of registers or memory location is very less, then definitely we can remember it by its name, right? Say suppose there are 10 to 15 students in a class, right? So a teacher can remember its name, roll number, and everything, and even know it personally as well. You know how, what is the nature of this student, what is the brilliance level or intellectual level of a student, what is the sincerity, etc., etc. If it is a class of 5 to 10 or 10 students, then the teacher knows everything about each student. But while if that would be a class of 200 or 500 students, it is difficult. I'm not saying teacher should not know or teacher is not knowing, but it is difficult. And again, simultaneously, if the class becomes 1,000 of students or 1,500 of students, right? So then it is next to impossible. So the thing is, if the complexity in earlier eras, the computational power is very less and the memory size and all these things are very less, so it is easy to know, remember the name, address, location, etc., right? So if say for example we have to add b is equal to a plus 2, right? In terms of b is equal to a plus 2, say this is suppose a, this is b, and this is for addition code, right? So it is easier to understand, like this is some assignment in A, this is some assignment in B, and this is addition of A plus 2. So we can easily remember these things because there are very few operations which can be performed. We should remember what is the code of operation, what is the code of subtraction, what is the code of multiplication. Each things if we are knowing, and we are there are fixed number of registers, so address location of register is also knowing, then it is easy to write machine level code, right? But in today's era it is not possible. We don't know how many even registers are there inside the machine, right? What is the capacity, all these things we don't know about it, right? So how it is possible to write machine level code in this era, right? So machine level code is not possible writing at that moment of time or in this era where the complexity computation power is very huge, and power of computation and computer is very highly powerful, right? Then comes to assembly language program. Assembly language is what? First is your machine language. In machine language, the only way of writing is all this in 0 1 form. There is nothing else. Everything is in the form of 0 and 1, right? Everything you should remember in terms of 0 1. But in assembly language it is not like that. Assembly language, you can say in this way, you should like move, mov. Mov is move operation, where a is the variable name and r1 is the register involved in the computer machine. Say suppose the machine, we are knowing the machine is having two registers R1 and say R2. So in machine level is a little bit more flexible than machine level language, because here we need not to remember the code, binary code for move operation, binary code for add operation, binary code of move operation, and again we are not remembering the address location of registers address part, which were there in the previous example, right? In the previous example in machine code everything was 0 1 0 1 0 1, but here it is not like that. It is more about some like move means move karna, value content of r1 का content जो होगा that will move into a, means whatsoever r1 में से suppose 5, so 5 is moved into a, so a is having value 5, then add 2 into r1, so value of r1 is getting added by 2, so value of r1 which is 5, 5 plus 2 is 7. Now R1 becomes 7. Now value of R1 again moved to B. So B, whatsoever B is there, value of R1 is being assigned into B. So this is your again movement. So this is little bit easier to perform, right? But again, if these are very small operations, then that is fine. But nowadays we are doing a lot of things. Just you can see, just for addition purpose, we are going to deal with these type of or that many operations, right? And for say suppose multiplication and everything, we need to write a lot of things like knowing the register, uh, assigning values and all these things, right? But again, in today's era, it is not much more feasible to write assembly level code, because there are many registers involved, there are many simultaneously many operations is being performed, right? But still it is easier and it is writable, you can say. Assembly level code we can write if you are working in core level, like in my at microprocessor level. If we are designing a small chip and we are performing some sort of like small operations for small things, then those coding is definitely being performed in assembly code, right? So if you are plugging any chip into some device, putting some like toys, etc. In toys, there are some this that level of code is being performed. So assembly level code is again writable and feasible to write, right? Because there are some fixed phenomena, or there are some fixed notations, or there are fixed syntax which we need to like move, add, multiply, subtract, sub, complement, comp, right? So these are the fixed operations which you can we have to perform. So definitely if it is fixed one, then one should remember, and then it can be writable as an assembly code, right? So assembly level code first developed in 1950. It is easier to read and write. Assembler converts to machine code and is still different from each machine. Definitely it should be different for each machine. Why it is different from for each machine? Because in one machine there are only one register R1, so that is fine. The machine code is this. If there are multiple register R1, R2, R3, R4, so definitely the way of writing can be different. There are multiple registers can be used for the same uh, task, right? So that is again dependent upon machine to machine assembly level code, right? Is that okay? All of you are getting what is machine level code, what is assembly level, assembly language, right? Now come to discuss about high level language. What is an high level language? High level language is basically language in which we are not directly dealing with the hardware, right? We are not directly interacting with the hardware. We don't even bother what is the configuration, what are the hardwares, what is the requirement, etc., etc. No. If we want memory, we just write something like int a, means we are declaring a memory of size a, of integer kind of sort of things, or some byte required, and its name is a. It is our nomenclature. Then computer should understand ki what programmer want to say. Like int a means program. As a programmer, I want memory size of which can contain integer, and it's named as a, right? So similarly, in high level language, it works like that. Like developed in 1960 and later, much easier to read and write, portable to many different computers. Language includes C, Pascal, C++, Java, Perl, Python. Right. So these all which we are talking about and which we are learning, those all are high level languages. Right. So if it is a high level language, then how it is being uh, how it is being recognized by the computer? then definitely it is required to convert those high level language into machine code or even assembly code, right? Some sort of intermediate code is required or some sort of target code is required to be understand by the system, so that why what we are wanted to do, that system should understand, right? So that is your high level code. Okay, so 1960 onward the development of high level language has been started, right? Prior to that we used to work with assembly language and machine language, right? Okay. The next is uh, some application, some history, like in early compiler, uh, there were in 1950s Grasshopper developed one compiler. Late 1950s Fortran has developed a compiler. Now basic other applications of compiler, like what, in latex we are having a compiler, but whatsoever we are typing in latex, that need to be like there are some code and that will be converted into application area, like PDF whatsoever we are uh, representing, that is again like converting into PDF. It is again a kind of code, or there is a compiler required which convert whatsoever we have typed in Word, MS Word form, that need to be converted into PDF. There is a something compilation is required. Verilog programming, VHDL, in which we are talking about is still, like in VLSI designing part, like in small chip we are providing some coding. So although over there we used to have a some compiler, right? Now major part, now compiler, the starting of the this particular course is from this part, major part of compiler. What are the major components of compiler, right? So the compiler involves whatsoever user or programmer is writing as a program. First it need to check whatsoever programmer is writing, whether it is correct or not. If it is correct, then only the second thing comes, that you how to convert it into machine language or assembly language or whatsoever, right? So very first thing is whether the programmer is writing correctly or not, right? So the whole part of compiler or whole functioning of compiler is being divided into two categories or two parts, you can say. First is analysis phase and another one is synthesis phase, right? In analysis phase, the correctness of program is being checked, or correctness of the code is being checked, or analysis phase involves the checking of correctness of the source code. And in synthesis phase, conversion of source code into some target program or target code is being used or is being performed, right? So the whole functioning is being categorized into two parts. First is analysis phase, another one is synthesis phase. And in an analysis phase, intermediate representation is created from the given source program. Components like I'm coming into that part just after this, right? So these are some phase, these are the phases of compiler, right? So an analysis phase, the checking of correctness is being performed. In synthesis phase, conversion is being performed. Equivalent target program is created from the intermediate representation obtained from the analysis phase, right? So obtained from analysis, what analysis phase does is it checks the correctness to whether the program is correct or not, whether the syntactically, logically, all these things, right? And then it will convert those things into some intermediate part, and then from that intermediate code the synthesis part starts, and it will convert those in section into target code generation part, right? Okay, so next is your apart from these things, like there are two major components, there are two phases. Sir, what is intermediate representation? Yes, we will come to that, don't worry. Right, so intermediate representation means, say like this, like A is equal to um, say B plus 3 and B is equal to B plus 2. Right, say suppose you need to find the value of A. Right. So in order to finding the value of A, definitely you need to first find, since the instruction is like this in this sequence, so definitely you need to perform find the value, modified value of B, and then only you can perform value of A. So here B is an intermediate. So again for this sort of things, like in order to convert source language to target language, so might be possible, directly it is not possible. This is target and this is source language. So source language is being converted into some intermediate language or intermediate source, intermediate program, intermediate, and then that intermediate part is again reconverted into target part. Right, say suppose for example, you understand English, I understand only French, so a compiler or an interpreter is required. Whatsoever I will speak in French, it will convert it into something English, and then it will translate it to you. Right, so some intermediate things is required in order to convert from source to target. Right, so that is all about intermediate representation and all. So we have a full topic on intermediate code representation part. Right, so right now just understand if there are something intermediate in between source and target which is required. Right, right now that would be sufficient to know about intermediate representation or intermediate things. Right, okay, fine. So yeah, good, keep on asking these things, right? No issue. Fine, so shall we move ahead? Now here we have discussed about the components of compiler. Now here, apart from those components, there are some add-on parts with compiler. Some tools often work in conjunction with compiler. What are those tools? Like uh, pre-processing, whatsoever the user, like in you can say in C program we used to write as include something something something, as include this, and then we start like programming. Right, so what are these things? These two part are called, has include part are called pre-processing. What is the task of this? If you don't include this, compiler is not able to compile it, the whole code. If you have used like cout or get ch, then it will throw an error if you have not included conio.h. Why is it so? Because conio.h header file contains the definition of getch function, cout functions, right? So the thing is, there are some preprocessor required which need to be processed prior to the processing of compiler. Right, so whenever original program or original source program is given, it need to be pre-processed. Then after pre-processing, what in C programming, what these pre-process does is, before compilation, all these pre-processing header file got open and got appended with the code. Say suppose my code is of 2 line or 3 line, and 1 line is of header file. So now whenever you must have felt that during compilation the whole program becomes 50-line code. Why is it so? Because these 2 lines are there, but apart from that the 48 lines belongs to this header file. Right, So this header file got opened and got appended with the code before compilation, because if the compiler doesn't know the significance of each keywords is being used, or any function which is used, right, then with how it will compile it, because it is not knowing the significance of those things, right? So pre-processing is very very important. So if we are having a preprocessor part, it will get appended with the code, and then it will get executed, or it will get transformed, or intermediate code is being generated, right? So first is pre-processing is required. The pre After the pre-processing text, it will pass on to the compiler, right? And then compiler convert target assembly code, and assembly code is again uh, can be converted with relocatable machine code, or machine code required, loader, linker to link with the machine, right? Or maybe external libraries also required, and then it will become the final absolute machine code, right? So these are some add-on components which is required for the compilers, right? Okay, so right, compiler conjunction tools. So first is preprocessor, second is assembler, right? So what is preprocessor? Preprocessor is basically, it is a source program may be divided into several pieces. The division of source program into many pieces and task of collecting source program known as preprocessor. Preprocessor is uh, before the processing. Can you please show the diagram again? Okay. Okay. Yes. Right. Is it fine? Don't worry. I will share this PPT. Right. To you all. I will upload it in the Blackboard. By today only I will upload it. Don't worry. Then preprocessor. Source program may be divided into several pieces. Task of collecting the source program known as processor. Right. Assembler. What is an assembler? Assembler is compiler. Compiler may produce assembly language as output. Assembler is easy to produce an output and debug it. Easier to debug. Assembly language process the assembler and its output. Just go through these things. Right. It is. These are very easy, and you must be knowing priorly all these things. Right. So that is all about assembling and conjunction tools of compiler. Linker. Functioning of linker is what? To link, say suppose कोई वेरिएबल यूज हुआ, राइट, कोई मेमोरी लोकेशन यूज हुआ, या वेरिएबल के साथ मेमोरी लोकेशन को लिंक करना. So that is the task of linker. Linker resolves external memory address where the code in one file may refer to the location in another file. Then linker will help to link that file, right? And loader is what? Again, if something is being demanded from some other location, right? So loader will load those things like value load karna, put all executable file together into memory for execution, right? Because that's why I told you ki prerequisites were computer architecture, finite state theory of automata, and basics of programming. So these parts are deal come from computer architecture. You should be knowing that ki how the computer is working, or how computer works, right? Because रैम में इतना स्पेस नहीं होता कि सारा का सारा पूरा सीड उसी में तुम डालो और उसके बाद वो वर्क करे. Can you explain the linker again? Fine. So say suppose if I'm talking in terms of assembly language, so move a comma r1. Now what is A? A must be some place of address location, right? And this is your A. And this A is for what? For a human or for a programmer, we know this address location is A. But in terms of computer or in terms of computer computation, there is nothing like A. ए जैसा कुछ कंप्यूटर में है ही नहीं. इट इज जस्ट वर्चुअल नेम कि इसका हमने वर्चुअली नाम दिया इस लोकेशन को ए, जैसे रैम है, राइट. रैम का ये जो भी है से यहाँ पे मैंने कुछ सेव किया और मैंने इन ए नाम दे दिया तो ये नाम हो गया ए. तो दैट इज वर्चुअल नेम, दैट इज फॉर माई सेक ऑफ दिस, कि हाँ ये मेरे लिए कंप्यूटर ने मुझे इसका नाम ए कहा कि तुम इसको ए के नाम से रेफर करो. मैंने बोला था कि मैं इस एक लोकेशन चाहिए जो कि ए हो, so it is A for me. Are you getting my point? So this is virtual thing. So whenever linker works come into action, it will link that memory location with my variable name, say A. So resolve external memory address where the code in one file may refer to the location in another file. That also be the case. Like वन फाइल में कोड है, से जो भी मैं कोड लिख रहा हूँ ये किसी एक फाइल में मैंने टाइप किया हुआ है या लिख रहे हैं, और मेमोरी का लोकेशन के लिए सिंबल टेबल होता है. सिंबल टेबल बताता है कि अभी इतना मेमोरी लोकेशन फ्री है, इतना अवेलेबल है. जैसे ही मैंने ए लिखा तो ये सिंबल टेबल में जाके स्टोर हो गया कि हाँ मुझे कौन सा मेमोरी लोकेशन मिला है ए के नाम का. से लोकेशन जैसे मान लो यहाँ पे जितने सारे लोकेशन है, 20th लोकेशन, तो ए के नाम का ये 20 लोकेशन जो है वो ए है. तो यहाँ पे 20 लोकेशन से ये है, इसमें जो भी कंटेंट है से 5, सो दिस वैल्यू ऑफ ए इज 5. तो ये एक फाइल है जिसमें मैं प्रोग्रामिंग कर रहा हूँ. दिस इज अनदर फाइल जो कि एक सिंबल टेबल होता है, ठीक है, जिसमें जाके ये स्टोर हो गया वेरिएबल का नाम. और फिर ये थर्ड फाइल को ये मेमोरी लोकेशन को रेफर कर रहा है. तो ऑल दिस इज बीइंग लिंक्ड कि इससे यहाँ ये लिंक है और इससे यहाँ ये लिंक है. सो दैट इज द फंक्शनिंग ऑफ लिंकर. आई होप कि दिस इज क्लियर. अदरवाइज ऐसे मैं ये सारा वर्ड यूज नहीं करना चाह रहा था. आई वॉज नॉट wanted to use that symbol table or etc. Right, but still you have, as you have asked, so I have used explicitly over here because all these things we will discuss much more in elaborate way. This is just an introduction part. We are dealing each thing or whatsoever we will look across all in this subject, right? So in introduction I'm just giving you those ideas in brief way, right? So is that okay? Fine. So linker and loader is done. Then moving ahead with phases of compiler, which is very important. So check out those phases, right? Just go through. Maybe it might be possible. Is it visible for everyone? You able to see the pictorial representation of all phases? Okay. Fine. Okay. So there are total 1, 2, 1, 2, 3, 4, 5, 6. Code generation, or there are 6 phases of compiler. First is your lexical analysis phase. The program is being passed into this phase, and each phase is being it it works something, and it passes its output to syntax analyzer. Then syntax analyzer passes its output to semantic analyzer, then intermediate code, code optimization, and then target code generator, right? And all these phases is being interacting with these two things. If any error, says in lexical analysis phase, if any error is coming, right, it will throw to the error handler. An error handler will throw display to the user that this sort of error is there, right? And symbol table, right, just I have mentioned particular word symbol table to explain the previous example of linker, like a variable. So if a is a programmer use the term a, right, so where this a is linked with, so it will search with the symbol table, and if it will find the justification for a, or it will find the proper definition of a, or a is being defined, or a is, if it find the a is there, so it won't throw error. It will recognize, okay, what is a, what a is, and then it will move ahead. Suppose without any declaration part, say without writing int a, right, sometimes it might be possible by mistake we used to do b is equal to a plus c, or a plus d, or something something something, and we forgot to declare b, right? So suppose if we forget to declare b, it means there is an error. So it is throwing an error. So first it will go to there, and it will search for b, and it won't find b, then it will throw an error ki, oh, no, there is no b is there. So there is no b, definition of b is not found. So it is throwing an error, right? So that is the symbol table. It is being the table is being maintained for each variable, and many more things we will talk about whenever it is required, right? So is it fine? So lexical analyzing phase, syntax analyzer phase, all those phases is interacting with symbol tables, right? And again, it will, if any error it will find, it will throw error those error into error handler to display to the user, right? So this is the basic phenomena of your, or these are the phases of compiler. You should remember these phases. First is lexical analyzer, second is syntax analyzer, third semantic analyzer, fourth is intermediate code generation, fifth is code optimization, sixth is code generation. Or sometimes it is used to say like uh, this phase as a target code generation, right? So this phase is also called target code generation, right? Intermediate code generation, it is a code optimizer. So now broadly, what are the functioning of these? Intermediate lexical analyzer. Lexical analyzer basically checking the correctness of each word being used, right? Like int, comma a, b, table name का जैसे, say suppose I have written like int a, comma b, comma c, and say मैंने नाम दिया 12, right? So what are these? This is an declaration for integer a, b, c, and here I have mentioned 12. So what is that 12? 12, is it a proper variable name? No. So it will check int is proper, correct token, or correct keyword. That is fine. A is a identifier. Fine. B is an identifier. Fine. C is an identifier. Fine. 12 is an identifier. But for identifier, it is like it should not start with digit. If it would be A2, it's fine. But it is just 1, 2, it should not start with digit. right? So again, this is not a proper identifier. So lexical analyzer will check the correctness of each token. What is token? Token means what? Like int A, comma B, comma C. These all A individually, B alone, C alone, int. These are your tokens. Smallest word to be recognized. These are called token, and it check the validity of each token. So that is the broad task of lexical analyzer, right? I hope lexical analysis is clear to all of you. All of you clear? Okay. Then it comes to syntax analyzer. What is a syntax analyzer? Okay, fine, fine. Syntax analyzer is, say, just take an example of syntax analyzer. Like here I have written int a, comma p, and done. Means what? What I have forgot over here? I have forgot over here semicolon. It will check the whole string or whole thing, and then it will say, you know, syntactically this sentence is wrong. Syntactically this sentence is wrong. What's wrong with this? The wrong with this is it is having missing semicolon. Or say suppose I have written like uh, here int a space b and semicolon. So again it is a missing syntax, like comma is missing in between a and b. So again it will throw an error. So syntax analyzer will check the syntactic error. If there any syntactical error is there or not. Say for with for loop. Say I am written for loop, and you have some mention something, and then colon, then mention something, and then comma. So again it is an error. For loop required two semicolon. So this is a syntactical error. So all those syntactical error is being recognized by syntax analyzer, right? Then further, semantic analysis. Semantic analysis, I told you in previous class as well. There are logically, there are syntactically correct sentence that may be logically wrong, right? Say like that. Say suppose, uh, mm, okay, right. So suppose I have written like. Uh, Fine. In the last class, I have given you an example like the dog is eating the bread. It is correct sentence. And the bread is eating a dog. It is also grammatically correct. So syntax analyzer doesn't find any error in that sentence, but this sentence is passed to the next phase, which is semantic analyzer, and semantic analyzer analyze that, you know, this sentence is correct syntactically, but there is no logic. Logically, it is not correct. So it will throw an error. So logical correctness is being examined at semantic analyzer part, right? So it means if fundamentally whatsoever the programmer wanted to do, is it doing like that or not? Or is there any error? So semantic analyzer will provide those sort of errors or those sort of things, right? Like some time you may feel that in writing a C program you may feel that there was some warning, right? So warning, who will issue? Semantic analyzer. Means syntactically everything is fine, but semantically there are something wrong, or there are something, if it is wrong it will throw an error. If it is something suspicious, it will throw a warning, right? Say suppose uh, float value, if I want to assign a float value in an integer, like say there is a float, float float a, and then I wanted to float a and int b equal to a. Suppose I have written like this. So what? So it is fine. Int b is equal to a एक वेरिएबल है जो कि b में इसका वैल्यू असाइन हो रहा है. There is no error as a syntax point of view, right? But semantically, what semantic analyzer will do is semantically, yes, since there is no error, that is fine. But logically, again, if I wanted to assign any value from a which is having a into b, that is again fine. Semantically, again, there is no much more issue. But the thing is, if float value takes 8 byte of memory and integer value is having only that much of size of memory, right? So whatsoever the mention in these areas, right, that value may be discarded, right? So semantic analysis analyzer will throw a warning to you. You may lose the precision part because it is having only integer, say 5. So and initially the value of a was 5.2. So 5 here and 0.2 here. These all are virtual representation. This is not the way like कि 5 ऐसे होता और यहाँ पे 2 होता है, इस तरह का नहीं होता. But just I'm just illustrating you for demonstration purpose, right? So 5.2. So what it will do is it will just store only 5 at b. Why? Because b is an integer. It may have only that much of size, right? So it will discard all those additional part and it will just store 5. So semantic, since this is not a logical error, right? So it is not throwing an error, it is a warning. Or it might be some strict programming language was there, so that may throw an error as well. But it is again a flexibility to given to the user that it may okay fine, I may lose the precision, that is okay for me, so I can write like this, right? So again it is depending upon the programming to programming whether any programming is allowing these sort of errors or these sort of things or not. If programming doesn't allow these sort of error, then it should be an error, otherwise it is a warning, right? So semantic analyzer works in this way, right? This is fine, this is logically it is syntactically it is correct, but logically it is not correct. Why not correct? Because float is having higher greater size or bigger size than integer value, and we are assigning greater value into integer. That is not logically correct. Yes, what happen is that if we are having a big container, we can accommodate a small container in that, that is fine. But we are having a small container, how you can put big container in that? So it won't be put it up, it won't go inside, right? So that's the basic thing. Okay, so that is all about semantic analyzer, right? Now come to intermediate code part. Intermediate code generation. Okay, I think time is about to over, right? So is there any issue with this? These part we have discussed, and these are called analysis part. Listen, these all are analysis, right? So this is called analysis phase. Analysis, right? And these are called synthesis phase, right? So this is analysis part, this is synthesis part. Are you getting that point? Analyzing part is being used to check the correctness of things, and synthesis part is conversion part, right? So Is that okay? Analysis phase, we have seen that analysis phase, intermediate representation is carried from the given source program. Component like lexical analyzer, syntax analyzer, and semantic analyzer. These comes in analysis phase, right? So analysis phase, just checking the correctness of your program. If there is wrong, it will throw an error. If there is something little bit wrong, or it may throw a warning as well, right? So this part we have discussed. This we will discuss in the next class, right? So hope everything is clear to you all. If not, then let me know, or go through I will upload this by today, right? And you may go through these things, and you may raise your question in the next class as well, right? Okay, fine. So with this note, I am just leaving the session, right?